Go ahead.
Did you by chance see my email at all?
Did I by chance see your what?
My email at all?
Was it recently?
Yeah, it was last night.
Last night?
Yes, sir.
You called off the top of my memory. I will check after. I'll make a note here to check.
Oh, yeah, me too.
You check for mine too. That'll be Anthony Valise.
I sent you an email.
There's an email from you I should look at. I'll take a look.
It was mine.
Okay.
All right.
Me too, sir.
Jeez.
Okay.
And Evan Curzon.
Okay.
Yes, sir.
All right. So let's get going. Welcome back. Hope everybody had a enjoyable Easter as much as you could anyway under the present circumstances. But it was nice to this methodology of teaching, which is the best we got right now. But hopefully everybody had a decent break and to kind of kick it back in gear for another 4 or 5 weeks. And then we can put a bow on this thing and move on. All right, I got some housekeeping chores and some announcements to go over, and then we'll jump into the lesson. So some of these you've probably already heard from your previous classes that came out yesterday's morning staff meeting. And the rest, and a couple of them are important, probably not so much for you guys, but for the latecomers. There's been some issues on Zoom. I've even got calls late at night saying something happened in a particular class and needs to be investigated, because there's other people looking at these Zoom videos in addition to you guys, because they're recorded, they're posted up on YouTube. There's dignitaries, trustees, and other administrators all looking at these. So just keep that in mind with what we're doing. So to minimize kind of people being in class that's not supposed to be there, these are the policies they've asked us to follow. I'm the messenger. I'm not the, I didn't create the message, but I'm passing on. You've got to have an identifiable username, all right? You can't have Carpin's crib or something like that on there. It's got to be something I can recognize as you being you and not somebody else. You got to have your camera on. If not, we got to make alternative arrangements. You've got to be in by the start of class. I'll be tolerant for a minute or two late, but if you start exceeding that 3 or 4 minutes late, I'm not supposed to let you in. All right. So the only alternative is if you want to get some of those 45 points lost by not attending class, you're going to have to watch it on YouTube and then write a 5 or 6 sentence paragraph kind of summarizing whatever it was we covered in class that particular day to confirm that you actually watched the video. So be in class at the start of class. No vaping, no hats, no food. You can be wearing hoodie sweatshirts. You just can't have the hoodies on. Can't, like Mr. Carpenter, you can't have the hats on. Again, just part of the decorum of the classroom. And you get your desk can't be your bed. Okay. Any questions, comments, concerns, complaints? Reference those deals. Probably most of them you've heard from your other teachers. We're all supposed to be kind of following the same policies and procedures. All right. Real quickly before I move on, just to make sure you're not here, Daughtry Griffin, Jenkins, and Victor Johnson.
What up, Walt?
Anybody else out there? Did I miss anybody? That's the 4 I got missing. Okay. Our last day of class is, it's actually May 21st for this class, all right? Our last day of class is May 21st, all right? There's Victor Johnson right there. I didn't see your name. You got a different name? It's Victor, okay. I give you credit for being here. All right, so our last day of class is May 21st, which means I think we only got about, after today, about 9 more classes together. I'm probably going to cherry pick a couple sections from here on out that are more pertinent or more important for us to get you up to speed on, for particularly you guys that are going to maybe move on to pre-cal next year or calculus AB. So we're going to cherry pick a couple sections to wrap up the year. you've probably already heard there's no semester exams in this class as well as any others. And I'm sure you're probably disappointed and depressed about that. And since there's no semester exam, each quarter, third and fourth quarter, are going to each count 50% instead of the 40-40-20 ratio that we normally use. Blackbaud is current. I've spent a day over break on each class trying to get you up to date. It's possible I'm still missing stuff from you folks, maybe through no fault of your own. You know, Blackbaud was down for 5 days. Those first couple of weeks of going to this style of learning, there's things that could have fallen through the cracks, not intentionally, but just through technology and sheer volume, lack of understanding on my end and maybe your end of how we're getting information back and forth from each other. So just check behind me. If you see you're missing something that you submitted, don't put it in Dropbox. Send me an email with it attached, because
Sir, I did
very,
that.
listen up. Dropbox is very cumbersome because I've got probably 7, 8, 9 Dropboxes per class times 5 classes, and I'm actually picking up another class starting tomorrow. So that's going to, you know, it's voluminous to try to find where these things are, and a lot of people are putting, you know, a quiz and a classwork homework problem set Dropbox and vice versa. So it's a little bit of a treasure hunt to go find. Now, there's some of you, and you're going to have to check behind me, and I'll actually just tell your name. 5-1 quiz, Miles Bunch, Henry Carpin, Jaden Daughtry, Reese Griffin, Henry Guire, Brandon Jenkins, Aiden Johnson, Victor Johnson, Evan Kurzanet. I don't have a 5-1 quiz from you.
Sir.
Let's,
I emailed it.
hey, just let me explain something.
Oh,
I've got 6 quizzes sitting over there with no names on it, okay?
tell him, sir.
Unless you've got a very distinct handwriting, Mr. Baird, I don't, you know, I can't just arbitrarily assign a name to it. So if you go to Blackbaud or you just heard your name called, email me that quiz. You've probably got it sitting there on your desk or in your notebook right there, because there's no name on it. I said I got 6 quizzes between this class and the other class with no names. And some of them have typewritten answers. They did it typewritten. And so, of course, no handwriting to maybe recognize there. And like I said, unless your handwriting is very distinct, and I've kind of gotten used to what your handwriting looks like, and I can name a few, then I can't, you know, arbitrarily put a name on a quiz that doesn't have a name on it. And that's just to be fair. So just, if you did it, and you sent it to me or put it in Dropbox, just email it to me. Don't put it in Dropbox. It's going to get lost there. Just email me the new quiz. Questions on that? Now, if you didn't give me the quiz at all, and I get a quiz from you, and it's not one of the 6 I got sitting over there, then you are going to lose some points for not submitting in a timely fashion, because it was due. When was it due here? I think back. It was due like on the 10th. Yes, sir, Mr. Carpin.
That's what I emailed you about, because when I looked on Blackbaud, it said it was submitted, but I had a 0 in for it. So I re-emailed you the quiz.
Okay. Yours is probably one of the ones with possibly.
Okay.
All right. Any other questions or concerns with reference to that? You're going to have to check behind yourself, because, like I said, things probably, maybe you've submitted things, but they've gotten lost somewhere between your bedroom or your kitchen table and my desk here at school. I'm actually, there's a little less than a handful of us here that are actually teaching at school. I come into school just because I get more done and using the whiteboards and all. I don't happen to have whiteboards all over my house. So just resend it, and I'll take a look at it, and we'll get it incorporated. Fair enough? All right. So let's pick up where we left off, and I know it's been a while. Just before Easter break, we were doing dividing polynomials, right? And we were working on that Thursday, the 9th, I believe it was, on 5-2, problem set 3, or it might be labeled 3A. And it's the one that actually had a real nice kind of step-by-step recipe on using synthetic division, okay? And just to kind of get us all back up to speed, the synthetic division, you know, there's two ways to do these. We can use either long division or synthetic division. And having taught this for probably, I don't know, 4, 5, 6 years, and I'm not trying to steer you one way or the other, it seems like the majority of you guys prefer the synthetic over long. And most likely because you didn't do a whole lot of long division with the advent of calculators in the classroom, even in elementary school and middle school. So you didn't have to practice, become very proficient in long division. They both accomplish the same thing. You pick which methodology you believe is best and easiest and most proficient for you. There's only one exception to that. And we'll talk about that at the end of the class here. I'll give you an exception of when synthetic actually doesn't work. All right, so with that being said, I took problem set 2, and I think if I remember correctly before, it looked better with the lights off. We cut them off. Is that better with no lights?
Yeah.
I want the lights on. Okay, so what I did, this is problem set 5-2, number 3 or 3A. Here are the answers for the odds, 2, 3, 5, 7, 9. Let's see, but did I get the evens in? And the evens too. Hopefully you can see that. 4, 6, 8, and 10. Okay, so hopefully you've completed that problem set since you've had, 12 days to do it. And what I'm asking you to do is to look at your answers. Hopefully you've boxed them or circled them versus these answers, okay? And see if hopefully they match up for the most part with each other. And then I'm gonna kind of walk back through, I don't think I can put it all on the board. In a minute here, I'm gonna slide down and I'm gonna walk you back through that synthetic division. Now, a couple people had emailed me and said, I don't understand how to do the synthetic division. And so, of course, I re-steered them because I think on this problem set, which you should have, had a real nice recipe here. And I didn't look at the Khan Academy version of synthetic, but someone said that was kind of hard to understand or follow Khan, which is kind of unusual because he's usually pretty easy to follow. All right, I'm gonna stand out of the way and I'll just talk. There's another great video source, and I've used it a couple times. I think in this class and the others. It's called patrick.jmt. And I actually like him as much, if not more so than Khan, because if you haven't Googled him, and you just go to that site and then just type in whatever, like dividing polynomials, you just type that in and it'll give you a list of videos or vignettes to watch. And I kind of like him in that the camera is kind of like over his right shoulder, and he's there with his right hand on the desk with a big kind of manila pad, and he uses a big dark black Sharpie. He's got a beautiful handwriting, and it's almost like you doing it. And you're just kind of looking right over his shoulder. He very clearly and concisely explains the process. So you might use that as a resource. Just write it down, patrick.jmt, if you don't have it in front of you. And use that as a resource on anything in math that you want to see another person's perspective. Like I said, I kind of just like his format because, Khan uses the blackboard and you don't see him and he's got colored pins and all, and it's very neat. He talks very clearly, but this guy's a little more clear, concise, and it's more like you would do it. You're looking right over his right arm and right shoulder as he works the problem. So use that as a resource. And I'm going to slide down so you can see the evens there. Let me see here. All right, let me make sure this is in there. Okay, so right here, I didn't do them all, but I took number 8 and I did the synthetic division. It was 4x cubed minus 25x squared plus 4x. Come on a little closer. plus 4x plus 20 divided by x minus 6. So we bring the coefficients down in their signs, just like they're written. And I do it right below it, so that way it's less likely to make a copy in here. Negative 25, negative 25, a 4 and a 4, and a 20 and 20. All right, then we draw a line, leaving a space for another line of numbers to go. All right, so our divisor is x minus 6, and this is about the only place that you could make an error. All right, so we're going to divide by 6, but we change the sign of whatever that constant is. So instead of a negative 6, we use a positive 6. We put a little half box around it so it doesn't get misconstrued or confused with the actual thing we're dividing into. All right? So once we draw the line, we bring the 4 down just as written. That's what the arrow is. And it's 6 times 4 is 24. And one thing we're doing here, let's see here. Grab there we go. Instead of subtracting like we do in long division, in synthetic, we're adding. So negative 25 and plus 24 is a negative 1. Then we go 6 times negative 1 is a negative 6. 4 plus the negative 6 is a negative 2. And then we go 6 times negative 2 is a negative 12. 20 plus a negative 12 is a positive 8. All right, so what these numbers represent here is the coefficients or the constants of this. And it addresses that we divided all this by negative 6, but we never addressed dividing also by x. And how we do that is we just, if I divide everything by x, it's just going to be one less exponent. So x cubed now becomes x squared. X squared divided by x is x. 4x divided by, so 4x divided by x would be just 4, but in this case we've done the math. So there's no variable here. And then this is our remainder, plus 8 over x minus 6. Questions, comments, confusion? Very good. Okay, so any discussions on the answers I put on the board here that I could clarify? Pretty good?
Definitely.
Say
For the problem set, for the steps, I was confused. I thought like for some reason you always bring out 1 is like what it was saying. But I figured out now, like when it's like divide by like, I mean the one you were just showing, like it's divide by 6. Like you put the 6 on the outside. I made that mistake by putting 1, like the example did.
Yeah, because they were dividing by x minus 1, so they used a positive 1. Let me see if there's an explanation here. Let's see. Well, if you read up at the top there, it says a procedure to divide a polynomial by a binomial using coefficients of the dividend in the value of r in the divisor. So the divisor is at x minus 6, 7, 1, whatever it is, all right? And the r is whatever that constant is. R is negative, use positive, and vice versa. So what's in that little half box is the value of r. I call it the constant of that binomial that you're dividing into the polynomial. Other confusion? I can clear it. Okay. So what I want to do is we're going to do one last final problem set for this section. All right. And my previous class ran along, and I was trying to get it on Blackboard so you could actually print it out. But if you give me 30 minutes after this class is over, I'll have it attached to it. And it's going to be problem set 3B of section 5.2 of dividing polynomials. So it's kind of a combination of all different divisions that we did in the previous problem sets. And this is going to look real similar. I'm going to walk you through. There's a total of 13 or 14 problems. We're going to do 4 or 5 of them right now. So you're going to have 7 or 8 to do. And like I said, if you just give me about 30 minutes after class is over, I'll have it loaded up in Blackboard. And I'm going to just kind of walk you through. I'm going to do a couple synthetic. I'm going to do 1 or 2 long divisions for those of you that want to use long division. And there's a case where you have to use division. I'm going to explain that. So let's see here. We'll talk about that kind of at the end. That'll probably be a bonus type problem. All right. So any question we kind of jump into this third 3B problem set and last problem set for this section. What I would do is just do it on loose leaf paper, and then when I load the remaining problems on Blackboard, or if I have time, I'll write a couple more on the board so that you've got them. And you can just do it on loose leaf paper. You don't have to do it on a printed copy of 3B, and then just drop it in the Dropbox before class 2 days from now. Fair enough? All right, let's see here. All right, let's see. I want to get you in, but I want it to be a little bit large so you can see what's going on. There we go. Let me know if I get out of bounds here. All right, so we're going to divide this polynomial by this binomial. And we can't do like, we did early in this section where we had maybe like 34f squared plus 16f plus 8 divided by 2f. Or I divided 2f into that and 2f into that. Well, this is a monomial, this is a binomial, so we can't do that. So our only option to solve this is either synthetically or with long division. And I'm going to do both on this one so you get a taste of both, okay? I'm going to erase this guy for right now. Okay, so if I did long division, this is what you're doing. You've got f plus 2 divided into f squared plus 7f plus 10. That's the problem. I'm going to change ink on it so it doesn't get mixed up with the previous problem. All right, so I'm going to work from left to right, and I want to zero out each one of these to the very end, till everything zero outs, or I end up with a final remainder. All right. So the first thing I want to zero out is f squared. So I'm really looking at f squared divided by the first half of this binomial. All right. So f squared divided by f, we did this back in section 5.1, is equal to f, right? There's one f, or f squared divided by f is f, right? So with long division, remember, we keep every variable with identical exponents stacked on top of each other. So I'm going to put the f here because it's not a constant, it's not f squared. So now I'm going to multiply long division, f times my divisor. So f times f is f squared, which is what I wanted, and f times 2 is plus 2f, right? Now, different from synthetic division, I subtract. So that's why I kind of want to steer you towards picking one method or the other and not bouncing back and forth, because I'm afraid you could use some long division tactics with synthetic or vice versa, and then we end up with a mess. So we're going to subtract here. So f squared f minus f squared, that zeroes out, which is what I wanted. And now I've got 7f minus 2f, which is 5f, right? Then I just bring the plus 10 down as written. So now I'm focusing on what does 5f divided by f equal? Well, it equals 5, right? Because that equals 1. So I'm going to put plus 5. So now I'm going to multiply 5 times my divisor. So I got 5 times f is 5f. I got 5 times 2 is a plus 10. All right, now I'm going to subtract again. All right, 5f minus 5f zeroes out, perfect. 10 minus 10 zeroes out, perfect. So there is my final answer. This polynomial divided by f2 equals f plus 5. And what's, something that you want to relate it to, what are these two things? Anybody notice anything what's going on with f plus 2 and f plus 5? If I multiply these two things, I would get this, right? And here, remember the old, the product of two numbers is 10. The sum of the two numbers is 7. 5 times 2 is 10. 5 plus 2 is 7. So it's almost, it's almost like factoring. Or it's close cousin is factoring.
How'd you get, I see how you got 5f plus 10, like the first line, like how did you subtract 5f plus 10? Like how'd you get the second?
This line?
Yeah.
Where did that come from?
Yeah.
All right, so it was 5 times f.
No. All right. And then you just subtract.
Yeah, and we're just subtracting this line from the line above it,
All right.
as opposed to you're adding with that synthetic methodology. So let's look at it. Any other questions? Let's do the same problem as a synthetic. All right? So the f squared comes down as 1, the 7 comes down as 7, the 10 comes down as 10, right? And we're divided by f plus 2, that's our divisor. Remember, so we reverse the sign, put a little half box around it, okay? Draw a line with room to write numbers. The 1 comes down as written, right? So that's 1. Now it's -2 times 1 is a -2. Remember, now we're adding, opposite of what we did with synthetic or with the long division. 7 plus a -2 is 5. So now I got -2 times 5 is a -10. 10 plus a -10 zeroes out, right? So now we got to address, we addressed the dividing by 2, but we haven't addressed the dividing by f of this binomial. So we just take 1 less than the exponent of the first value of that polynomial. So this becomes f plus 5 and no remainder. So there's our answer, which is the same thing we got with synthetic.
I think synthetic's more confusing.
Say it again.
I feel like synthetic's more confusing than long.
Okay, that's fine. If you feel more comfortable with the long, go with the long. They both do the same thing for you. And if you did a lot of long division, maybe in middle school or up, 6th, 7th grade, or 5th, 6th, 7th grade, did a lot of long division, you may be very good in long division, and that just comes easier to you. Hey, if that works better for you, go with that. They both, I'm not going to hold you. You got to use long division. This one, you got to use synthetic, and this one, long. No, whichever one, they both, you got 2 tools there. Pick which one you're most comfortable with. All right. Any other questions? Okay, that was number 1. What I want you to do, I want you to solve this one using the method of your choice. This is actually number 2. Write the number down so you don't have to repeat these. Divided by, so I'll read it to you if you don't want to look up and you write it down. It's 2x squared plus 3x minus 4 as the polynomial divided by the binomial x minus 2. Okay. So I'm going to let you do that. I'm going to give you 2 minutes, all right, to work that one out. And then I will walk you back through either method or both methods if you want. Okay. Just take a minute, write it down. Let's see if we can work out any of the kinks or bugs.
Mr. Gaffney.
Yes, sir.
So if you divide 2x squared by x, would you get x?
No? Let's look at it. I had this. This goes back to 5-1. Right? So let's kind of look at this. It's kind of 2 parts. As x over x and 2 over 1, right? So the 2 just stays as is, right? 2x squared divided by x equals 2. And x squared over x squared divided by x is the same as this, right? X times x over x, right? So that simplifies to 1. So our final answer is 2x. 2x squared over x equals 2x. Right?
Oh, okay.
You move the camera.
X times x equals 2x squared.
Okay.
Move the.
Sense? All
Can you
right.
move the camera down some real quick?
Am I too high? Sorry.
Just for a sec.
Yeah, no problem.
Oh.
No, I'm looking at a little 1-inch screen. trying to keep everything in line. Okay. So which way would you like to see it work? At least I'll do both if we need to.
Long division.
Long?
Yeah.
So I'm going to erase this. Let's see if I'm still on screen. Yep, I'm good. Okay. So let's do this. I got x minus 2 divided by plus 3x minus 4. Okay. So we want to work from left to right, getting each one of these to zero out. But we just talked about 2x squared divided by x. What do I have to multiply x by to equal 2x squared? And I had a little drawing here. We knew it was 2x, right? All right, I put this here because remember, you've got to match up the same base with the same coefficient. So x to the first over x to the first. So 2x times x, we already know because we've talked about it, is 2x squared. And 2x times a negative 2 is a minus 4x, right? Now I'm going to subtract. Remember, I'm subtracting with long division. So that zeroes out. Perfect. All right. I got 3x minus a negative 4x. Be careful the double negative, which now equals a positive 7x. Right? The negative 4 then is going to come down just as written. All right. So now I'm going to look at what does 7x over x equal? Because that's going to give me my multiplier for x to get 7x to cancel out. Well, that becomes 1, right? So it's 7. Excuse me. So I put plus 7 here. 7 times x is 7x. Perfect. That's what I wanted. So I can cancel it out. 7 times negative 2 is a negative 14. Now, once again, I'm subtracting the bottom from the top. 7x minus 7x. That zeroes out. Perfect. I got a negative 14 minus a negative 14, so that's the same as plus 14. So that's the same as positive 10, right? So that is my remainder that isn't divisible by x minus 2. So my answer is 2x plus 7 plus 10 over x minus 2. You may remember from your middle school or up last parts of elementary school, remember when you divided, 9 into 621, and I'm just going to make up an answer. Let's just say it was 71 with the remainder of 3. So you wrote 71 remainder R3, remember that? Or you could have written it, maybe they had you write it as 3/9, okay? Which simplifies actually now to 1/3, not a good example, but that's what that remainder is. Right? This is not divisible by that x minus 2. Is that what everybody got?
Yes, sir.
Any confusion before I move on? Anything I can clear up? You guys kind of know the drill. You just got to sit there. If you sit there for 20, 25 minutes and works 5, 6, 7, 8 of these in a row, you become pretty proficient in doing these. All right. Now, I'm going to throw you a couple curveballs and watch out for us now. Let's see. All right. Let's see. All right. This is actually problem number 3. I'm going to erase 10. I'll come back to 10 later. All right, so this is problem number 3, and I'm dividing a cubed minus 64 is divided, my divisor is a minus 4. Okay, this is one of the watch out for, be careful of scenarios. And why it is closer is because for this to work, you've got to account for every base with the exponents going down in sequential order. So we start with a cubed. For this to work, we need an a squared, an a to the first, and then that constant 64. Since we don't have them, we've got to create a placeholder to solve these, whether we're using synthetic or long division. I'm going to do both with this one because this is kind of one of those ones that could bite you if you don't remember this. You've got to account whether you're using synthetic or long, for each base with each consecutive sequential declining exponent. So we've got to calculate for an a squared and an a to the first. So how we do that? Let's see, I'll do long first and I'll come back, okay? So we got a minus 4 divided into a cubed. We don't have an a squared, so I'm just going to put 0, a little 2 there to remind me that's squared. And then another 0, that's a to the first, whole placeholder, minus 64. So we got 3, 2, 1, none. Does that make sense so far? 3, 2, 1, none. And we need those as placeholders to make this work. And again, you're going to have to do the same or similar thing with synthetic. All right. So first thing I'm going to look at is a cubed over a. All right. Let's see. Do you see that? Yeah. So a cubed, a to the third over a equals a squared, right? So I've got to multiply this by a squared to start eliminating what's under my what's under my dividing symbol here. All right. So a squared is going to go right over to the second power symbology, remember, because everything, the base and the exponents have to line up vertically. So if I go a squared times a, that's a cubed. A squared times negative 4a is a negative 4a. Okay, you say, well, what do I do now? I got all these zeros. How do I incorporate that? You just do the math as it's written. Don't just, do what it's telling you to do. Don't get hung up like this is kind of weird or unusual. Just let the numbers play out using the exact same methodology. So a cubed times a cubed zeros out. That's what you wanted to do. That's perfect. Now I've got, and this could be positive or negative, doesn't matter, it's 0. So I got 0 squared minus a negative 4a. So that's a positive 4a, right? So 0 minus a negative 4a is a positive 4a because I subtract. Now this 0 comes down, right? So now, how many a's are in 4a? So it's this, it's 4a over a, right? 4a over a equals 4, right? Oops, I'm sorry, I told you wrong. That should be squared. Let me back up. Real quick. I did not carry the a squared. I was thinking I was multiplying by a. So let me just clear this up. A squared times a is a cubed. A squared times negative 4a is negative 4a squared. Now I subtract negative 4a squared minus or from 0 is a positive 4a squared because I've got a double negative. Does that make sense? I steered you wrong just a little bit there. Let me just backtrack to make sure we're clear. Again, this is a squared, right? This came from right here. Not to get too many arrows and make it more confusing than it is. All right, so the 0 comes down. And now I'm going to look at 4a. How many a's are in 4a squared, or 4a squared divided by a, right? So that is equal to what? 4a, right? Because I got 4 times a over a, right? To simplify that, it becomes 4a. Any questions or confusion on that? All right, so 4a, so the first power, so it's going to go over the first power vertical kind of placement holder. So 4a times a is 4a squared, which is exactly what I wanted and needed. And 4a times a negative 4a is a negative 16a, right? We're subtracting once again. So 4a squared minus 4a squared zeros out. And 0 minus a negative 16a is a positive 16a. Are we good so far? All right, and then we bring the negative 64 down, just as written. So now I'm going to look at how many a's are in positive 16a. So I'm actually looking at this. I'm going to erase a little bit just so I stay within my screen here. So I'm looking at this. 16a divided by a equals what? It equals 16, right? Because that becomes 1. So I'm going to put plus 16 right here. And the constant over the constant, so that all that matches up vertically. So 16 times a is 16a. Perfect, that's what I wanted. And 16 times negative 4 is negative 64. All right, I'm subtracting the bottom row from the top, 16a minus 16a, zeros out. Negative 64 minus the negative 64 is adding 64, and that zeros out. So there is my final answer, a squared plus 4a plus 16. Does that make sense? And are there any questions or anything I can clear up? You guys are quiet.
Yes, sir. I'm good.
Good. Do you want me to work that one synthetically also?
Yes, please.
All right. Is it okay if I erase this? Everybody got what they need? All right, so let's do it synthetically now. You better come up with the same answer. All right, so we still have to do the placeholder stuff. So this comes down as 1, right? Because there's no coefficient there, so it's 1. I don't have an a squared, so I got a 0. I don't have an a to the first, so I have a 0. And I got negative 64. So cubed, second, first, constant. All right, so I'm dividing by a negative 4. We got to remember to reverse the sign. That's one pitfall you got to watch out for. So there's the setup. All right. The 1 comes down as written. 4 times 1 is 4. All right, now we add. We're adding, right? So 0 plus 4 is 4, right? Now we know 4 times 4 is 16. 0 plus 16 is 16. 4 times 16 is a positive 64. Negative 64 plus 64 is 0. Perfect. So now I'm going to go back. I started with a cubed. I got to address this a because I only addressed the negative 4 in this synthetic part. So a cubed over a becomes a squared. All right. So this 1 is actually 1a squared. I'm not going to write the 1. So that's a squared plus 4a plus 16. And we're done. There's no remainder. The remainder would have been where that 0 is. And we did get the same answer, right? We just will check. Yeah, same answer. Mr. Johnson, I like your disco ball.
Sir, watch this.
Play a little Saturday Night Fever.
Sir, look, it's a light, sir.
Suki!
I thought it was a disco ball. So you live your Saturday Night Fever days. Little John Travolta.
Yes, sir.
At ease, sir.
Funny,
might-
sir. Funny,
You guys
sir.
might be too young for that.
Sir, that was funny.
Awesome. Yeah.
Suki.
Who
I'll be at
said
the comedy club later.
who said the
Walter.
B word?
Porta cat?
Let's see. Any questions there? Any questions?
All good, Suki.
We good, Suk.
Okay. How are we doing on time? Oh, man. So there's 1, 2, 3. You got that done.
Ugh.
Okay. Let me skip to one last thing. I was going to try to do problem number 9, but it's more the same. Oh, if I had this, just to refresh your memory, all right? If I had this here with a negative 1, what is this asking you to do? What is that asking you to do? It's a multiply or divide.
Can you show it again?
Can you not see it?
Oh no, it's just, I'm on like the speaker.
Yeah, it's
here.
kind of faint. I added a negative 1. You're going to see the problem set. You're still dividing, right? Because at negative 1, you take the reciprocal. So that's the same as 1 over a minus 4, right? That's a reminder. We did this in 5-1, but just watch out for that, particularly on number 9. Okay, when I load the problem set on to Blackboard here after class, there's 4 problems, and I put a note on the problem set. And here's one of the problems. Okay, what's different about this problem than some of the others we've worked? What's different, particularly probably looking at the divisor,
As
Oh,
it,
they're
right?
there's
Wait.
It's 2x instead of just x.
There it is, right there. Mr. Baird is right. There's the coefficient of X is something other than 1. And what's that do?
It changes
Pulls
the
you
entire
into doing long division. Synthetic won't work with this guy. You've got to use long. So I'm going to walk you through. This is actually number 10. This is number 10, okay? Number 10. I'm going to walk you through it. So we've got to use long division. Let me make sure we've got room and you can see. So we're going to go 2x minus 3. The mechanics are the same, except that you've got to recognize, and there's a note on the worksheet, because of the divisor, this x has a coefficient other than 1, you've got to use long. And that's the only time I'm going to kind of push you into long division. Synthetic works every other time, except if this was something other than 1. So we've got 4x squared. The mechanics are the same. Minus 2x plus 6, okay? All right, so what I'm going to focus on is I want each one of these things to zero out as we work left to right. So I'm going to focus on what is 4x squared over 2x equal, right? And that equals 2x, right? 4 into 2 goes 2. X squared divided by x is x. So it's 2x, right? So 2x times 2x is 4x squared, which is what I was striving for. And 2x times negative 3 is a negative 6x, right? Okay, so back to long division. I'm subtracting, I'm not adding like with synthetic. So negative 2x minus a negative 6x is plus 6x. So that's a positive 4x. And the positive 6 comes down as written, right? Okay, so here we go. So now I am going to multiply. Let's see here. Yeah, I'm going to multiply. So now I'm going to look at what is 4x divided by 2x equal, right? Because I want that to zero out. And that equals 2, right? So the plus 2 goes right here. Again, constants, base to the first, base to the second. 2 times 2x is 4x. 2 times negative 6 is or negative, 2 times negative 3 is a negative 6. I got ahead of myself. All right, we subtract 4x minus 4x, zeros out. 6 minus a negative 6 is a positive 12. So that is my remainder or leftover. So my answer is 2x plus 2 plus 12 over a remainder of plus 12 over 2x minus 3. And so there is your final answer. Okay. So again, there's two cautions. This being one of them. If the divisor, the x value has a coefficient other than 1, you've got to use long division. The other caution is if the sequential exponents skip a number, such as square root of the first or whatever it is, you've got to put a placeholder in, whether you're using synthetic or long. Okay? So we've done 1, 2, 3, and 10. Once class is over, give me about a half hour. I'll load the remaining problem set on there. Okay?
When will they be due?
Have it ready for class on Thursday.
Okay.
If you get it done, drop it in Dropbox and I'll give you the credit or points for it. And I'm just going to spend the first part of class going over any confusion. And then we're going to jump to the next section. Then I'll load the quiz on there, which will look like this problem set, but not, this has 14 problems. We'll probably have like 12. And you'll have to do that Thursday or Friday.
Do we need to like put these ones on our homework sheet? Like the ones that we just did already?
Now 1, 2, 3, and 10. If you just want to copy the problems off what I'm going to attach to Blackboard, you don't have to do it on that. You don't have to print out that problem set and do it on there. You can do it on loose leaf paper. It's fine.
Okay.
If that's what you were asking.
Yeah.
Yeah. Okay. Oh,
Okay.
put these on there. I just do it all together. I mean, you don't.
Yeah.
I already know we've done 1, 2, 3, and 10.
Yeah.
I don't need to see them. I'm not going to focus on them. But it'd be nice to have it all together.
Yes, sir.
Let's see. We're a little over time. Any questions?
I'm all good.
Make sure you do these and work out any kinks, because I'm just going to kind of talk about this a little bit at the beginning of class on Thursday, and then we're going to move on.
Okay.
I'm not sure where we're going next, because with only 8 or 9 classes left, I'm going to cherry pick a couple sections that will benefit you the most in pre-cal for those of you guys that are going on a pre-cal. All right.
All right.
Any questions before we still a bye-bye?
Bye, Suki.
Thank you.
Thank you.
I
All right,
said,
everybody,
All right.
everybody hang in there. I still do off 2 to 2:30 every day, so I'll be around there within minutes after this. Be 2:30 before I get this loaded up on Blackboard. So if you got any additional burning questions, whatever, hop on office hours. You also pick up 10 points towards your quarter or your weekly rep grade. Like Mr. Neighbors, he gets a 2-for-1 special since I've got him in 2 classes.
Neighbor.
All right, I think he already signed off.
Bye, Suki.
sir, sir,
All right, we'll see you. Unless you got
sir.
All right, Mr. Johnson, make sure you go ball spinning for the next class. With
Sir, I have
a
a question.
little disco music to go with it.
Yes,
Yes,
sir. Sir, do we still have to meet once a week after class?
if you want that extra 10 points to get 100 for the week, because it's 45 for each class,
Sir, I'll see you in 6 minutes.
10 points for checking in during office hours, just to say howdy doody, and I like Mr. Johnson's disco ball for.
Sir, I'll see you in 5 minutes.
All right, see ya.